Don't open it yet. All right, maybe open. Hello, Internet. Oh, perfect. Well, welcome everyone to the Microsoft Reactor and to Stockholm Machine Learning Club. I put the welcome back sign here. I realize this is probably for most of you the first time here, so it's not really a welcome back, but welcome. A little bit about the space that we're in first. So the Microsoft Reactor is essentially an investment space from Microsoft to host events like this for community events, but we also hold other workshops, whether they're covering things like AI and ML or any sort of technology or startups. So we actually have one coming up, which will be me speaking at it, about building your first AI project. So if you are interested in machine learning or AI and you've never done anything before and maybe you think some of the things you might hear about today is still so much to you, this is going to be kind of a walkthrough of how to actually get started building an AI project. And we talk about Azure and we talk about Microsoft products, but this is not just a place to sell Microsoft products. So we're completely open to other technologies and things like that. So if you are interested in hosting a talk or hosting another meetup here, let Erica know. She's the program manager and she manages the schedule. I'm just the guy with the microphone. But yeah, Stockholm Machine Learning. So it's been actually 811 days since our last meeting, so quite a long time. The last meeting was supposed to be our 1-year anniversary of this meetup. So I promised everyone cake, and I actually delivered. We were so close to actually having this meetup. It was like really, really close for the pandemic. I actually went out and purchased a cake, and I froze that cake for many, many days thinking this will blow over in 3 months. We'll all be meeting back. We'll get some hand sanitizer and be fine. Obviously, that did not happen. And I held onto the cake for about 600 days. Then I had a moment of weakness and I ate the cake. So that's why there's no cake for you today. But hopefully maybe our 2-year anniversary, there's not going to be any sort of global pandemic or something that will ruin that celebration. But yeah, what we are about here. The joke is that we would love to be called the Stockholm Machine Learning Club, but meetup.com does not allow that many characters in a meetup name. But that really is the core of this group, is to be able to educate and provide knowledge and share that out. So even if you're not an expert in machine learning or not even working in machine learning or AI now, this is a safe space for you to come, learn about things and also share the topics. So even if you are starting out and you just found out about what a neural network is, it's completely cool for you to come and do a talk about what a neural network is, because there probably is someone in the audience who doesn't know that. And even if they do, it's always great to get a new perspective on a topic that we all know and love. So again, really about learning. Our first meeting, I think we had a high school student, a designer from a bank, and a few PhDs. So it was quite a spread of knowledge. And then randomly me. I don't know where I fit in that category. So yeah, again, everyone is welcome, whatever you're doing. It's all about the interest of machine learning and AI. And actually, the cost of membership. So I don't know if anyone paid anything to come here, but membership is completely free. But there is one small cost, is that we hope one day that you will speak here, because we don't come and pay anyone to speak, or we don't get some famous people to come do amazing talks. We have a visitor today, but he was just in town. We didn't pay him to come. We don't have meetups if we don't have speakers. And I got really smart and I put a little survey question when you join the meetup now, if you say like yes, no, or maybe. So if you said yes, I will definitely find you to do a speech. If you said maybe, I will also find you. And if you said no, that's a maybe in my eyes. So probably in a couple months, you will be up here speaking, hopefully. We really driven this by people volunteering and doing talks. And you can join these amazing people who have done talks in the past. Some are in the audience today, or at least one. So we've had quite a grab bag of topics, as you can see. So we had something about reverse engineering and using AI, just a general talk about NLP, like a survey of what NLP is and what it does. Even predicting crypto prices, that's always hot. And AI and ML can do that sort of stuff. At Intro to TensorFlow, so nice. We like to see code, so it was a nice coding workshop as well. John, who's in the audience, can tell me exactly how to say that word again because I always forget. What is it again? Nefertafel. Yeah, some Viking chess game. That's how I looked it up. I was like, I remember Viking chess, and it came up first hit. So he built a bot to play that game. And then we also have two great speakers, and Aisha completely messed up and didn't put that there, but you'll be talking about AI in education. And Alan, I put this as Gans Dance, or Dance Gans, I don't know, something. But he will also be talking that. So you could be on this board next time. And speaking of next time, so like I said, we have one meetup here through the Reactor. So we have a meetup group that's separate if you want to join and you're interested in those sorts of things. We also have a climate hackathon coming up in partnership with our sister meetup group, Oslo AI. So like the slightly richer, more oil-filled Stockholm Machine Learning Club, and they are doing something with the climate. I have the more details I'll post on the meetup group. It'd be super cool if we could make a team together and win it. That would be great for Sweden. And then, yeah, so that'll be from the 7th to the 9th. There'll be more details there. And then our next meetup actually will be June 8th, and it won't be building your first AI project. So that'll also be on there. So it'll be hopefully some two lucky individuals I will find to speak on that. And maybe since it's between this climate hackathon, if you're interested in like sustainability or green AI or any of that stuff, would love to have you talk here so we can be like on brand. But yeah, so today's event is kind of special. So normally we have two speakers, like a break, and then another speaker comes. But we actually have a guest today, all the way from the Netherlands. I think that's how you say it. And he actually hosts a show called A Bit of AI, but I won't steal his thunder. You can go ahead and explain what that is and how we're going to run the event today. You're going to set up all the camera, yeah. Where are you going to stand exactly? So I'm sorry, I'm like moving around, and you're like, so
No, that's
there you
perfect. Cool. Thank you, and thanks for everyone joining here. It's going to be a really good evening. So we have like two talks tonight. We're going to do that first, like 45 minutes. And then we're going to dive into a panel that is called the A Bit of AI show. And the A Bit of AI show is all about how people learn in tech and how they actually got into the field of AI. So I'm going to invite the speakers of today and Corey up to the stage to do like a small panel with me. I will ask some questions about what they studied, what they are exciting about in AI, and then there is a lot of time for your questions. Like if you want to start a career in AI, kind of where do you start? And these people will know the answer, or maybe I will know it. So that is going to be the program for today. And the show will be kind of live recorded and live streamed from this camera. And then later on we will add sign language to it, and the show will be published on the Microsoft channels. So if you have a question, just wait for me to bring you the microphone so you are also in the stream, or feel free to come up. So then I think we're going to try and see if the screen share is going to work and invite our first speaker onto the stage. Did I forget anything? Code of conduct?
All good.
All good, all covered here? Perfect.
Cool.
researcher at Department of Computer and Systems University, and I'm working in the area of technology enhanced learning. I'm working in AI domain, AI area of in education, and also building AI-based tool to assist students, teachers, and educators. From last 5 years, I'm working in machine learning, and also other by using other techniques of AI in healthcare domain as well as in education. But in last 3 years, my focus was on education domain. So I wrote some papers. I have some conference publications, conference paper publications, some journal articles. Okay, the agenda of my today's presentation is here. Firstly, I will tell about the role of AI in education domain. After that, I will tell about which kind of techniques are being used in education by using AI, like machine learning, learning analytics, explainable AI, and NLP. And after that, I will explain that how these techniques are used in different use cases, like prediction of student knowledge level, to predict that what will be the student knowledge level and how much grade he will get in his final exam, this kind of information, and also to self-regulate students. Self-regulation means to make students in this way, because nowadays students go to classes, they are very big classes, like massive open online courses are there. So it's very difficult for students that which kind of material they should study and which kind of material they should not study. So we developed tool that self-regulates students, tell to the students which kind of reading material you should read, and you will get good grades in your exams. And also we develop tools for teachers for personalized learning of students, because different students have different learning ability. Some students can easily capture different things, some students cannot easily capture, so they have different levels. By using these tools basically provide the personalized support to the students. Because we use these techniques, especially explainable AI, or machine learning techniques we use in these tools, and these provide personalized and adaptive support to the students, and in this way it facilitates to teachers, because when there are many students in machine learning and deep learning courses, there are many students, they are taking in online classes, and even in physical also there are many students. So teachers cannot provide personalized support to each and every student, because each student has different cognitive ability they have. But by using these tools that I will give you a demo at the end, by using this tool, students can get personalized support. And also these tools are useful for the quality education at educators level, like institutions. So, and at the end I will show you the demo in which we use these techniques, and these are the use cases of them. So now first the question is, what is AI in education? It's basically the implication of artificial intelligence to facilitate different stakeholders in the education sector. Well, this definition is a little bit vague, so need to clarify it. Which are the stakeholders, which facilities, and how to facilitate. So there are many different stakeholders of an education domain, like students, teachers, educators, tutors, mentors, researchers, organizations. All are the stakeholders, but our focus in our work is students, teachers, and educators. And also what kind of facilities are provided. These are like, as I told you in my previous slide, that personalized support to the students, and also the provide intelligent recommendations to the students. They could get good grades in their exams. this kind of facilities for students, for teachers, to support them, to structure their curriculum in this way that student can get easy to understand them, this kind of information. And for educators, how to facilitate the educators, like to improve their passing out rate of the students and decline the dropping out rate of student. Obviously, when their passing out rate will increase, then obviously the repute of that educator will go to up. So how to provide these facilities? By using different AI techniques. The next slides are about this. So firstly, I will tell about the knowledge tracing, in which we use techniques of learning analytics and machine learning. Knowledge tracing is basically to track student knowledge data and predict their performance in the future. Like it has basically two major applications, like assessment level and question level. In assessment level, knowledge tracing is like this: students' data during the course is collected, like for example, if you want to predict that what is the student's performance in his third or fourth assignment or quiz, then you take data from the previous assessments and what was the score in the previous assessment, and also the log data, that which reading material he studied, which concepts he studied, and which kind of lecture slides he studied. And because everything is on learning management system, because in each and every learning environment, learning management system are uses like Moodle and this kind of. So this data is collected, and after performing some analysis, that is called learning analytics, that lies under the learning analytics. So after performing analysis on this data, it is find out that what will be the performance in the upcoming quizzes or assignment during the course. And it is very useful for students, because students get motivated that if they get this prediction that they will fail, then obviously they will try their best to more study and to get pass in their exam. So, and also in question level knowledge tracing, performance prediction in question while attempting exam. It's like this: students are sitting in an examination hall, and they are doing exam or attempting a quiz. So this question level knowledge tracing is very interesting, like this, that it tells that whether the next question student is going to attempt, it will be correct or not based on the previous data. It's a combination of learning analytics, analysis of the student's learning data, and the machine learning that performs the prediction. Well, here is some vector representation of this assessment level knowledge tracing. Like students' LMS data is collected, that consists of his scores and also the students' views, and that log data that provides students views, that how long he watched the different video reading material, for how long time he studied the different reading material. So this kind of information is given here. After preprocessing, then feature engineering, new features are feature engineering is basically that the data gives some feature, and based on those features, new features are derived. So feature engineering is conducted there, and after that ML model building happens, and after that some it is prediction or classification. If we perform any classification algorithm, for classification we perform ML model building, then it classifies the student. High achiever means that the student will get high grades or low grades in their exams. And this is the question level knowledge tracing. It's from my one paper. The other process is the same: student data, preprocessing, feature engineering. This is the basic thing that are used in in this question level knowledge tracing. It's basically an ensemble approach. I used a light gradient boosting machine algorithm model and multi-headed self-attention knowledge tracing model. So by using these, their prediction, I assigned their weight based on their predictive outcomes and find out that whether the next question that a student is going to attempt, it will be correct or not. And another difference between this and this previous slide is that here is the student's LMS data, but here is the questions data. Questions data is when we take the questions data, then questions, what are the concepts are in questions, they are used in it, and context analysis is conducted like by this model. And now go to the next use case, and it's by using explainable AI. It's a very hot area nowadays. So in every domain it's used, healthcare, education. So it basically tells about the reason of predictive outcomes, that how this model find out this particular prediction. What is the reason? So for example, if in previous slide I showed you that the prediction was high achiever and low achiever, then this explainable AI basically tells then why, how he will be high achiever and how he will be the low achiever, why a student will fail, what is the reason. So this explainable AI explains these things. It delivers explanations of the predictions provided by machine learning. So its many use cases are, firstly, it's very significant to provide intelligent recommendation to students about their studies. It self-regulates students. It's useful to get good grades in exams. So I will explain in next slide, explainable AI to support student self-regulation. How it self-regulates the student by using explainable AI. This is just a picture, like a person. There is a student who's following this self-regulation and then gets success. So, but it means that self-regulation is something that need to provide students. So how it can be provided? By explainable AI. So how explainable AI works? This is the log data, and it's basically the different students massive on MOOC, like massive open online courses. Many students are enrolled and they are learning by online. So the data is taken and all of the students who are taking online courses, they are basically studying by a dashboard. Behind that dashboard is any LMS that's called Learning Management System. So Moodle is a very popular, many universities are using, and in our university, Stockholm University, Moodle is used. Many students are studying there. So it's basically this work that I'm going to show you. It's from Stockholm University data, students' data that we collected from a programming course, Python programming course. So we collected students' data. It was about different activities. Each course has different modules in which there are different activities. So these are different activities, like students are set to watch videos and different reading material, and also there are some quizzes, assignments. So in our work, our focus was on these quizzes and assignments to get that what were the students' grades in these assessment tasks. And then we applied explainable AI on it. It's basically different models are used in explainable AI. Model agnostic approach we used in the previous work by using Lime library. Example based approach we used in this work, and use the counterfactuals. It's a very it's also very pretty hot area. People are working in it in different domains. So it was very useful in it, because first we used this, but it didn't provide us the better results and better performance, but it worked very well. And after implementation, it basically tells about, these are the features. These are the student features. What are the student score in quiz 1? What is the student concept level score in a quiz? And also the different features, actual values are given here. And this is basically the data of one student who was actually current time was low achiever. He will get less grades. He was a low achiever. We took his data and applied counterfactual explanations, that is basically explainable AI. When we applied over it, then that algorithm gave us some results that if student, for example, if he's getting programming knowledge, his programming knowledge is giving 50, and if he will get 75 score, and similarly in all features these updated scores, then he will be high achiever. So and this algorithm basically gives many counterfactual explanations. So the most prior one we take and then deliver to student, and it's very useful to provide student recommendations that you have to do, like for example, this is and student is told that programming knowledge, if you get this study to this level or till this time, then you will get 75 score. So then you can get good grades, as because your current state is low achiever, then you will achieve the high achiever status. So in this way this technology works. And then this is the development, that was implementation, and this is a prototype of that work, in which this is the prediction, that what was a student's prediction, that he will be high achiever or low achiever, what is the prediction, 30% chances and 70% chances, and here is the recommendations are given. Next comes natural language processing in education. It's a very powerful tool. It provides many useful applications in the area of education. We have developed and still working. On one application we have worked, and the other one we are still working. First is a knowledge-based students grouping, because in courses there are many students. It's very difficult for students to tackle each and every student based on their learning ability. So group students based on their learning level, their learning students' understanding level, knowledge ability. So they are separated, group them. And the other application is the automatically exercise generation for these specific groups, because it's pretty easy to give exercises to student. Okay, you do this, it's very important for your practice. But to deliver exercises that are according to their understanding level, to improve, to targeting a particular particular groups, they have same understanding level, and to deliver those exercises based on this, considering this scenario, then it will be more useful for the students. Considering all these ideas, we worked on it. So okay, now knowledge-based students grouping. It is the NLP plays an important role based on their understanding about different learning concepts. In a course, one course, there are different concepts, like if you take Python, there are looping concepts, conditions, and some other like there is a if-else condition, switch statement. So there are different concepts. To then, what is done in this work, in this application, that students' understanding based on these concepts is found out, and the students who have almost same understanding about this particular set of concepts in a course, then they are grouped. So this is the basic idea behind this application, and we call it these are different knowledge groups of students, and it's very useful to provide them personalized support, and also collaborative learning. It's a very famous, and people like to collaborate with each other and work. So when different students group together, then they collaboratively work, and it facilitates to teachers to provide them personalized support. And this is the pictorial representation. Here is the, for example, there is a there is an answer sheet, in which in an answer sheet there are questions, answers, and score of each question is given there. So when questions are extracted, then from each question is basically targeting some concepts, one or two concepts, or one particular concept. So concept extraction is done. How concept extraction is done? Spotlight, many other concept extraction algorithms or methods are there, so you can use it. So this concept extraction is done, and after collecting the concepts and the scores of the student, we cluster the students, and different knowledge groups are generated. And now is the automatic exercise generation based on students. Its aim is also the same, of improving their concepts understanding, because such grouping helps in different ways to self-regulate, to provide adaptive support, and self-directed learning. And here is a picture that different knowledge groups. Each knowledge group is a group of students who have same understanding level. And then the concepts, all concepts that their understanding level for different concepts, these concepts are given to the books, are matched with the given to these books, PDFs, and lecture slides. They are studied during the course, and then based on these concepts, and the text is generated, is taken from these material, is reading material, and then that text is given to the NLP pre-trained model. Different models you can use, unified learning language model. It's also very good. It is used, and then question and their answer generation. It's automatic generation of exercises, and obviously helpful for teachers and also for students. And now here is a demo. It's not, sorry, I could not share the its direct link. It's just a picture. So at the top there is a student's current status, like student is getting B grade, and there are the how many exercises, lecture assignments, and theoretical exercises he has attempted. And here is the link, here is the click. When you click it, you can set that that grade you want to achieve. For example, here is a student. If you want to achieve the grade A, just you have to click on A, and the recommendations are given there. And it will be that you should read this, you should read this. It's basically based on counterfactual explanation that I told you at the start, that counterfactual explanations generate these recommendations. And even also tell them that the priority of this, if you will do this task, then its priority is middle. And if you go this task, its priority is high. You will early get your target. You will early become the high achiever. And if you will do this, its priority is low, so it will take time. And here is the NLP applied to generate exercises. So just student click on it and a quiz open that is based on his current knowledge status, and the all exercise is given. He attempts all the questions, and at the end there is solution also. So, well, it's all about education, AI in education. Yeah. Any question? Yeah.
We also have online questions.
Yeah, perfect. Then you can have that microphone.
You hear what I'm saying online?
Okay.
No,
Yeah.
they can't respond.
Yeah, it's very simple. You have an example there from Stockholm University and Moodle, right? And the problem, of course, with AI and so on is the data in. So if I'm doing, say, an introductory course in programming, it's very likely I don't do the exercises on the learning platform. I will do exercises that I find online or something like, because they are a lot better, and then you don't have any data on, at least not for the students that work the most. And actually try to find material to work with. So how do you handle that? Do you like incentivize students? I mean, if it was something with work, you could just say you have to work with this platform, but
Like actually we worked for one course that was a Python programming course that I told you for Stockholm University. And if you talk about, basically we take data of student LMS data, learning management system data. So that is Moodle, mostly in most
I
universities.
know about Moodle and I use it. I don't like it, but the question is, I mean, if I'm doing an introductory programming course, I will have access to lots and lots of mocks, and the tail end on the mocks will be a lot better than the course at Stockholm University. Even if it's the best course at Stockholm University available, the upper tail end of the mocks will be a lot better, and I will have exercises in programming on a lot of online platforms. And obviously, I mean, you can't track what I'm doing. Even if you tried it, you wouldn't be allowed to actually track what I'm doing on all the external platforms. So you won't get the data where I train as a student and so on. So if I'm then having an exam in the end, you will have all these students. Why is he getting an A? He hasn't done any work, right?
No,
so you will get all these.
I understood your question. No, we can get data. There are some libraries you have to use and you can access data, but before accessing data, you have to take permission from the tutor, and after that you can, it's easy. You can get data from Moodle. It's log data, it's easily accessible, and also the other information, yeah.
Yeah, I mean, basically you have to use a pixel or something if you want to track me externally outside of Moodle. And if I'm doing the programming learning, I will do it mostly outside of Moodle.
Can
So,
I please
yeah,
give
sure.
an example? For example, we are studying in our class AI business consultants. We had a write code module as well. We were provided data camp, but almost half of the class went on YouTube instead and did exercises on their own. How can then that be logged into the system? YouTube versus data camp.
Okay, this system, basically the exercises, that data, the log data, we basically collect the students that when, for example, he go to Moodle, he checks, he reads different reading material, he watch different videos. This data is collected. The log data means this data, his views. We capture his views, that how at this page, how many times he went, for how long he stayed there, based on that. Okay, these are the basic features, and these features are used for using further for counterfactual explanation, for explainable AI. So basic data is like this.
Yes, I think your focus for model and both of them ask you if they use another resource. It's not in the model. And I know that many teacher design is not good enough because the student, most of the model, I know the teacher just deliver the material on the platform. This doesn't help for learning. My another question, this is you just use one course, and maybe I don't know the teacher design the course is really good for students, and they have other model course. Maybe the teacher design is really poor. How you use this AI predict students' competence, and yes, and you use the knowledge, use base of the Quizlet, but maybe many Quizlet just use multiple choice, right or wrong. But this is not just simply test the students' knowledge. It's not really the competence. How do you use AI to improve for this kind of situation?
Look, any AI technique, basically we use the previous data, okay? The data that students performed previously work. Either it's assessments or either it's views or this kind of information. We worked on Moodle because in Stockholm University, Moodle is used. So I have idea on Moodle, about Moodle, but didn't work on other LMS that you are talking about. But Moodle is, I think so, it's the popular one, and it's the top-notch LMS. So and it captures, it has every features that you are discussing. So
many schools have beat the platform.
sorry?
Many schools beat the learning management system. It doesn't many use model anymore. Even I know that many universities use Canvas, like many schools in Stockholm for York School or any other high school. Maybe they use Teams, use Google Suite. So they have many different learning platforms. How you can use this kind of AI to improve?
Yeah, just because I don't think you work for Moodle, so we don't have to beat up. I don't know if anyone's working for Moodle here, but for this point, I think is really great because you're illustrating using these techniques. You could probably expand to other data camp or more preferable things, and you're just showing us how you in this experiment use those techniques, and we can apply them to something else. So. Bad Moodle, everything else good.
No, that's actually where I was heading. I have a lot of questions, but I'm going to keep to the most important. So this is being developed mostly for, I guess your target is universities going into the online education, or is it mocks in general? Is it upskilling in businesses?
No, basically our target is the higher studies, online courses like MOOC, massive open online courses. We are targeting this, and also the other, we are testing this tool on currently on Stockholm University data, but our target is to capture these Coursera, like Coursera and different kinds.
Okay, so the framework of what you're gonna learn is kind of established and set on certain, how to say, KPIs or like certain achievement levels, so to say. No, as I said, like if you're going for higher studies, then they have already a lot of a learning program that students need to have come up to a certain level. So it's quite easy to then understand which level the student needs to be at. But if you would expand it into other subjects than just programming, how would you go about it?
The other courses, like courses, basically this is a problem that course data varies, course to course data varies. So it's very difficult that you make a tool, just one tool that is applicable for all course, all kind of courses. Like for example, if I develop tool for Python or different programming courses, and then you use it for in social sciences like history or this, no, it will be, because data will be different in that. But when you use, for example, the student, they are also using that learning management system that for this, considering this, I developed this. So then it becomes a little bit more easy. But if for example, in programming courses, you are given the questions are basically are decoding. You have to complete this code, or you have to find out this kind of which is the mistake in this code. But on the other hand, if there is a history course, or any other social science course, so obviously it will difficult. So that's why it's not easy to make a tool that is generalized for all courses. So it doesn't fit. Another approach can be you categorize different courses, like all programming courses. You make a tool for all other social sciences courses. Their features are resemble, the data structure is same. You make another. So that's
Cool. So we're going to take one more question from this lovely person online, and then you can obviously come talk to her, and then we'll take a break for Alan to speak.
Okay, I have 3 questions from the same person. I'm just going to choose one. The longest question. Or the last one. So John Mason says, we are still recovering from a once-in-a-generation pandemic, but outcomes from an online learning weren't so great. They were terrible. What did we do wrong? How can machine learning AI and LA help? Learning and analytics help?
Yes, it's a good question, and it is fact that online. But this is the purpose of this presentation, is to tell about that AI can play a role in it, but the development needs this kind of tools. This kind of implementation is required for students that they could follow them. So, but in different online courses, because that was a pandemic time, and obviously everyone was in that condition. So that's why maybe different people could not use the tool. So that's why we prefer that you go towards the tools development, and it will be useful for them.
Thank you.
Cool. Thanks. So we'll take a small break. You guys can chat on about your favorite MOOCs or what you need. And then Alan will come and talk about dancing. So hopefully everyone loves that.
5 minutes?
5 minutes, yeah. Or as long as you take notes. See you. Welcome back, Internet. And welcome back. We'll have Alan now talk about dancing and machine learning.
Yeah.
There you go.
Thank you.
Oh, you have a mic. You have a mic.
Yeah, I have a
Good.
mic, yeah.
Okay.
Great. So thanks very much for turning up this evening. This is my first time at the Machine Learning User Group. It's probably my first time ever at a not Microsoft User Group. I've really been involved a lot with the Microsoft community previously, but I think I've been attending various user group meetings since about 2004, a long time. So a bit about myself. I describe myself as a developer, trainer, mentor, and evangelist. I love working with new technologies and usually looking at kind of the next big thing. So when I was working at a shop where everybody's working in C, I was the guy who was working with Java. And then at a Java shop, I was the guy who was doing .NET. And then at a .NET shop, I was the guy who was learning stuff about Azure. Now I'm at an Azure shop, and I'm doing lots of stuff with the Microsoft AI technologies because we feel that we're going to get a lot more interest in projects from customers. And there's some great technologies and really rapid evolution. So I like to work in that space where things are changing very rapidly, and we're getting lots of new technologies to start looking at. I've been an Azure MVP for a number of years. I started out in 2005 as being a BizTalk MVP. We have an ex-MVP. Hank used to be an MVP for machine learning, wasn't it? And this is an award that Microsoft gives to people who put a lot of energy into the community. So I met up with Henk when we were involved with the Global AI Bootcamp, and I was working with a hands-on lab for that. That I might mention a bit about later on. I'm also, together with Henk, organising conferences. We ran the first ever AI Burst conference in Stockholm a few years ago. It was a glorious sunny day, and Henk and was it Wilhelm came over from the Netherlands, and we had a few Swedish speakers. We had a great single day event, and it's basically a free to attend these events paid for by sponsorships. And then we planned a second AI Burst, and then COVID happened. So we've kind of been on pause for a couple of years. We've now got a date. It's sometime towards the end of August, I think, and we're running one day here in Stockholm and one day in Amsterdam. It's going to be the same speaker lineup at both events, but hopefully we're going to get a room full of people and some good speakers, and it's going to be a great day. It's also going to be a free event to attend. If you want to follow me on YouTube, there's my YouTube link there. I'll probably mention it at the end as well. So a bit about the presentation. I was working with AI and machine learning, and stumbling around all of the videos you get in feeds on YouTube, and this video popped up, and it just really impressed me how they basically built this neural network, or trained a neural network, where you could take a source video of a professional dancer, you could detect the pose using an algorithm to be able to bring out the pose. So this is a bit like a neural network doing the same thing as a Kinect sensor would do, detecting the body pose from the actual body positions. Then you can use that detected pose to be able to take a not professional dancer and get the not professional dancer to follow the moves of the professional dancer. And it just blew me away. I was thinking, yeah, how the heck do they do that? You know, what makes this work? So I started looking in and investigating and thinking, well, this is done by people at MIT. I can't do this. I can't get this code to work. It's going to be really complex. It's going to require lots of expensive hardware to be able to get this thing running. So a bit about how things work. This is a service called the Azure Computer Vision, which is one of the Azure cognitive services. And what you can do with this computer vision service is you can basically feed in an image, and you're going to come up with a text description of that image. It provides things like face detection, object detection, all kinds of other things. But it will also produce a sentence, which is a caption for that image. So if you've got a big image library at your company, you can run all these images through the computer vision service. You can generate all your tags. You can then search on this, and you can also generate captions for these images. So what generative AI will do, and another really impressive example of that is the DALL-E project, is instead of putting in an image, you put in a sentence, and from that sentence it can actually generate an image from that particular sentence. So an illustration of a baby daikon radish in a tutu flying a kite, and it will generate these various images based on that. I don't know if I've got the actual link in here, if I need to Google for this. See if I can find it. And you can basically go in and look at this. It's currently running as a website. It hasn't, as far as I know, got the free text option to be able to type in free text, but you can actually select various chunks of the actual sentence here. So you can change this to an avocado in a cape, flying a kite, and it will come up with all of these images, and these are actually generated with neural networks from those particular sentences. So, exploring generative AI and getting to learn a bit about how generative AI works. There's other examples that you can look at as well. Pix2Pix is what the Everybody Dance Now project has been based on. And Pix2Pix is able to take kind of a simplified image and be able to generate a more complex image from that. So normally with AI we do something called dimensionality reduction. We're feeding in something with lots of features, lots of dimensions, and we're coming out with something simpler that's coming out of the network. And the networks are usually going down with lots of inputs and coming down to a few outputs. The Pix2Pix is able to take in, the actual images and be able to generate these images of buildings. It's been used a lot in various scenarios, such as with mapping data, to be able to take in, say, go to Google Maps and you've got the actual mapping data, and you've also got aerial photos. So they're able to actually synthesize aerial photos from map data. It's been done a lot in games. I think the Microsoft Flight Simulator was using mapping data to actually generate real-world images, based on those types of technologies. You can also play around with this technology. Here we can basically do something with cats. So what they're doing here is starting with a line drawing of a cat and actually generating an image of a cat. And that's basically going to run that particular model. It runs pretty slow on my laptop, but hopefully it's not going to take too long. And then you can basically work with your own images. And one of these here, you can see it's only got one eye, so I can maybe draw in the other eye and click on process and see if it's going to generate a second eye on that cat. Sort of, yeah. And some of these are more impressive than others. I quite like the building one. So if we clear this, if I do process, it's going to download the model. And then you can select the various things to place in this building. So I can take a door, I can draw a door, and then a window. I can draw a few windows. This is about the limits of my drawing skills. And then you can put in some columns. And it generates the building from that particular image. Again, we're increasing the complexity here of those various images. So going back to this, back to the actual deck and looking at how the Everybody Dance Now stuff works. What we're doing here is taking this actual pose image, and the actual network that we're going to be training is going to be taking in this actual pose data. And what we're going to do is pass that through the generative network, and it's actually going to generate a picture of a person in the particular position that we've got from that pose. Now this is doing it for a single frame. So if we want to do it for an animation, all we've got to do is to take a video of a professional dancer, in this case Bruno Mars, and then basically split that video into all of the actual sub-images and run that through OpenPose to be able to generate a sequence of poses. And then what you can then do is use the model to be able to generate a sequence of images and then compose those back into a video and be able to actually play the video. I can show you the actual results of that a bit later on. So if you do want to experiment with this, the code is available on GitHub. So you can basically go in and you can download this source code. I've pretty much made virtually no changes to the actual source code to actually run it on my machine at home and to be able to get it running in Azure ML as well, the Azure Machine Learning. So I did need to learn a bit about what generative AI is. There's a really great book up on there, hands-on generative adversarial networks with PyTorch. Most of the samples, I think Pix2Pix is running on PyTorch, and Everybody Dance Now is running on PyTorch. So it helps if you've got a bit of a PyTorch basics. Also, I decided to use a green screen for the background, so I bought a really big green screen as well. Set this stuff up in my living room to be able to do the actual recordings there. And When I was recording it, I was actually using, you know, if you've got any kind of a new mobile phone, it's going to shoot at 60 or 120 frames a second. This means that you get a lot of training data in a relatively short number of times. So I basically shot in quite high resolution at 120 frames a second to actually produce the actual source video. I tested this with my son first. He was the first volunteer that we used for that, to be able to generate the images. And then again, we use OpenPose to be able to generate the actual pose pictures like that. Then it comes on to training the model, which is time consuming. Roughly it took about 5 days when I was training at home on my home PC. This wasn't popular with the family. Basically you could tell when a training run had finished because it went quiet in the apartment. And the thing was running constantly 24/7. My machine is upstairs in the living room. You can hear it downstairs in the bedroom at night. So it is noisy. I'm planning my conference schedule to be out of the country when the electricity bill arrives, because you do need to run quite a hefty GPU 24/7, and that takes a lot of power. Alternatively, you can run it in Azure ML and basically save yourself the money doing that. Okay, so creating the actual target data, again, we're taking a professional dancer, we're using the OpenPose to be able to generate the target poses for that. Hopefully I can show you a bit about how this works. So I was actually running everything on my machine at home, but I've dragged in some of the actual data sets here. So I basically started out with a video, and this is the actual raw video that I was using. I don't know if this is going to open actually. Open with VLC. So this is basically what I shot myself doing an approximation of Bruno Mars dancing to be able to generate that data with a green screen. What we then do is use about 3 or 4 lines of Python and OpenCV to actually split that into the individual frames. And because I was shooting at 120 frames a second, I got about 22,000 frames out of a 3-minute video. Then we can use OpenPose, so hopefully I should be able to demo how that works. It will be incredibly slow on this machine because it really benefits from having a good GPU, but I think I've got the command line there for the OpenPose to be able to do that. And what this will do is basically take the source video and generate the pose videos for that. I think for some reason it's not running on the GPU on this laptop. I've not really figured out how to get that connected, but I think it's taken about 20 seconds per frame to be able to generate it on this box. Back home it's doing about 1 frame a second, which is okay. You can tweak around with the command line options so you can reduce the quality and you can increase the quality. Also with OpenPose I'm actually doing hand detection. Which is going to take a bit more processing time. I've got the option to generate the hands as well. You can actually generate the face, which will generate the mouth and stuff like that. And what that's going to do, as you can see here, is it's basically doing the same thing as a Connect sensor will do. If you've ever played around with Connect, you can actually get Connect to be able to generate this data using a 3D camera, but we're just getting this from the actual 2D image. Now it's not actually saving out the images itself. What it's actually saving out is the pose data, which is in these key point files coming out as JSON data. I think I can drop one of these into Visual Studio and show you what this thing looks like. So this is basically a JSON file, and it detects a number of people within that video, and then it's giving you the actual points here. So for each point, I think there's 25 points. You've got the X, Y coordinates in pixels, and then you've got the confidence that is the particular point. And it generates this for the body, and then it also generates this. I haven't generated any face key points here, but you've got the hand left and hand right there. The next stage is to actually generate the training data, which is going to be a combination of the input frames and the pose data. And that is basically going to generate the output data. And this is this graph train, which I think I've got set up as the actual startup project. So if I run this, what it's going to do is to run through the frames, basically taking in the pose data and generating the actual outbound files. And what this will do is, if you go into the train, it will basically generate the training set. So you can see that we've got the training images, which are coming out here, and we've got the training labels, which is coming out here. These actual files are being generated here. And this is going to be the input to the neural network. it's basically going to say, based on this particular input on frame 73, the required output is going to be, if we go down to frame 73 here, this particular pose. Then we're going to be training a generative adversarial network, which is the same technique as used in Pix2Pix, to be able to take those actual stick figure images and to be able to generate the actual images of the person. Okay, so if I drop back to the slides again. So once we generate the target data, we're going to generate the target poses. So this is going to be Bruno Mars and all of the positions that Bruno Mars makes. And in theory, if we feed in these target poses into the neural network, then we'll get an animation of me dancing like Bruno Mars. That's the theory anyway. So for the transfer, we're taking the target poses, as I mentioned, sending them into the neural network, and that's generating the actual images. The reason I've done it on a green screen is I use Camtasia a lot. I record for YouTube, I record courses for Pluralsight. So I'm pretty much a black belt with using Camtasia. I usually spend weeks sat in front of it when I'm working with Pluralsight stuff. And it's very easy in Camtasia to take out the actual background and remove the green screen effects. The GAN network is basically two networks that you're training. One of them is going to be generating the output, and the other one is going to be telling how good the output is and giving it a measure of quality. And both of these networks are basically trained together in this training process, and that's why it gets the name of an adversarial network. So the first epoch, when you run through, your output looks something like this, and as you're running through an additional outputs, you've got the generator, and then you've got the discriminator that's going to compare the actual output with what's come out of the network and basically give it a score. And the idea is that we're going to be improving the score of this, and the generator is going to get better at generating images. Also, the discriminator is going to get better at being able to discriminate the real from the fake data. And as you run through the epochs, you'll actually see the quality of the image improving as it actually does start to get running on the training data. So one thing that they do in the Everybody Dance now is they deal with temporal coherence, which is basically making sure that you get a more smooth or fluid movement in the actual dancing. If you just do this with single images, you're basically feeding in a bunch of single frames, you're getting out a bunch of single frames, and there's nothing kind of at linking those together. Dance is about movement, the fact that you're moving between one position and another position. So what the Everybody Dance Now was doing was taking the previous frame and the next frame and being able to actually use both of those as an actual comparison. So it's really tracking the movement or the difference between two frames, looking at the deltas there to be able to generate more smooth movements. I don't know if this has affected my results because the Bruno Mars video was at like 25 frames a second and I'm at 120 frames a second. So maybe the temporal coherence hasn't worked too well in that particular scenario. So when it gets to actually training the network, you've got this unfeasibly long command line that we're going to be using, which is something like this. So I'm running train full.py, which is part of the Everybody Dance Now. I'm entering the name of the model, the data set, the checkpoints directory, and various configurations for the actual network. And there's actually two training processes. We're doing a train local and we're doing a train global as well. So what this is doing is spinning up the network, creating the output directory. And then it throws an exception because we've got CUDA out of memory. These networks are big. They are really big. So I think it takes about 12 gig of GPU RAM to be able to actually load up the model and start training it. That's quite a lot. This little old laptop that I have has about 4 gig of GPU RAM. Now that's going to be a roadblock if you don't have enough GPU memory to be able to load up the model. You're not going to get very far with being able to train it. This is where Azure Machine Learning comes in because you've got a great choice of being able to choose different machines with different GPUs. So if you're not able to run it on your local machine, what you can do is push it into Azure Machine Learning. So I've got a machine learning workspace here. If I go to this thing here, this is basically a resource I have created. I can go into something called the Machine Learning Studio. And I can go to the compute environments. And I've got these various compute clusters here in different regions. One thing I've found is that the price of these can vary when you're going into different regions. So this one here, I've provisioned in West US. Two good things about that. Firstly, it was actually cheaper on a per hour price to run it in West US. Secondly, when we were working in Europe, people in West US are usually asleep. And one thing that you can do when you create these compute clusters is you can take advantage of low priority machines. This is like using resources in the Azure regions that are not being used. So if there's low demands on a region, it's going to be less expensive to use that. So if I go for dedicated, you can see that if I go on to a GPU machine, you can see that this machine is costing $1.17 an hour. If I go on to low priority, it drops to 23 cents an hour. I've also got the option of using a Tesla V100 machine at 76 cents an hour. So that's 3 times the hourly price, but in terms of cost for running a job, it's going to be cheaper to run it on the more expensive machine there. One thing you do have to be aware of is eviction. If you're running this for days and days and days on a low priority machine, somebody else may have a higher priority than you, and you might get your machine taken away from you. You'll get it back eventually, but you do want to build code where you can resume training if something goes wrong with your model, and you need to restart the experiment and continue from that last training point where you left off. So the code to throw this into Azure ML is not too complex. So this is everybody Dance Now master. I've pretty much dragged that down from GitHub and made very, very few changes to it. And this is the code that I'm using to push it into Azure Machine Learning. So if I just zoom in on this, what I'm doing is connecting using a configuration to connect to Azure ML, and that JSON configuration file has details about where my Azure Machine Learning workspace is located. I then generate an environment, and this is called Dance Environment, and it's coming from dancedependencies.yaml. I don't work with YAML, but I've heard lots of people talking about YAML, and I think I've got my YAML file here. Didn't include it in the project, but this is it. So what we're doing here is describing that we're going to be running on Python 3.7. We're talking about the various versions of PyTorch that we've got to use and the various other Python libraries. This is going to be used by Azure ML to prepare the actual environment so we can actually run the Python code in there. So that basically prepares that environment for us. What we're then doing is basically specifying the base image. So here we want to use an image that is going to support the GPU. So I'm selecting this image. It's got CUDA 10.1 installed. It's running on Ubuntu 18.04, and that's going to basically select the base image. I'm then selecting the compute cluster that I'm using here. I'm using the Tesla K80 on low priority, and that's going to be the name of the environment. We then need to get the data into Microsoft Azure. And another great thing about machine learning in Azure is it supports all of the actual data sets. So I think I can leave that page there. I can go into the data sets in this environment here. And you can see that I've got various data sets I've been using for Everybody Dance Now. So this is the one that I was using for one of the experiments that I did. And that should show us all of the files and all of the images that we've got. Fairly slow internet connection, but you can basically see all of the ping files that I've got in this particular environment here. And it doesn't matter if you're working with image-based or text-based data sets. It's fairly easy to load this stuff up, and it's just stored in a service called blob storage within Microsoft Azure. So that's basically how I'm managing all of my data. So what I need to do is to point the experiment at that particular data set. So I'm basically getting this Everybody Dance Now Bruno top and setting that as the data set. Now when we're working with these data sets, the data set is in a service called blob storage, but Python doesn't know anything about blob storage. It's expecting a folder full of files. So what we're doing is we're basically setting the data root to this dataset.asNamed input target dataset as mount, which will basically mount all of the data in blob storage onto the actual file system of the virtual machine that's going to be running this experiment. I'm then mentioning, as I had in this command line, all of the various command line options. So I've got the load size, label NC, number of iterations and number of decayed iterations, which is basically specified here in this scenario. This was just a test run, so I was only really doing one epoch and then one epoch where we actually delay the learning rate, and then we specify the output directory. Okay. So, I think that's the wrong thing that I'm running here. What I'll need to do is to select this as the actual startup project. Okay, let's try that again. And what I can do is run this. What this is going to do is basically take the code that I've got in the Everybody Dance now. I'm pointing at that actual repository. I didn't show you that actually. Yeah, this is going to be the source directory, Everybody Dance Now master, and then the actual Python script that we're running is going to be trainfull ts.py, the Python file. So by running that, it's just basically going to push that code into machine learning. Okay, so that seems to have worked satisfactory. If I go back to my Azure ML workspace, I should be able to go into experiments and see that we've got a new experiment. Now this one is currently running, I think, if I look at my compute pool, yeah, I've set the maximum number of nodes here to 1, and I'm currently running 1 experiment. So what I can do is actually cancel this experiment run, and I can just do cancel on that. And what that should do is basically, because that one's been cancelled, it's then going to actually start running the experiment I've just uploaded. So if I go back to experiments, it should actually change state on this one. You can see that this one is running. So they come out with all these strange words. Sometimes you get a cool word like mighty dinner. Sometimes you get something like sad pot or something like that. I'm not sure. They just basically generate these with these random verbs and nouns. So this experiment does seem to be running. We can go into the outputs and logs and basically see what's happening in this particular experiment run here. So we'll basically run through and give you all of the details on how the experiment is running. If I look at the previous one, we can maybe see some of the outputs. This one here probably got a bit further in its processing. So if I go to the outputs, into web and into the images folder. So this is showing the input labels, and then we've got the real images, and then we should have at the bottom some synthesized images there. So you can see this is coming from, I think it's saving it every 100 iterations or something like that as we go down these synthesized images. As we sort of scroll down, the quality gets better and better and better as it actually runs through. So you can basically go through and basically analyze and see how the experiment is running once it's running in Azure ML. Okay, so I'll drop back to the slides a bit about the background of Azure ML. We work with our data set, so we can generate a data store. We can use various resources for that. We can load up, tabular data, files, images, and so on, and use that for the data set management. It also supports features for being able to do, if you're working with, say, object detection, and you've got to, upload 10,000 images and draw bounding boxes on them. It will be able to, divide that in. So various, you can have a team of people going in and training and putting labels on the various projects. It supports all of the things like that. Provides the computing capabilities. It also provides other mechanisms for being able to work with. So you can work with notebooks. You've also got the Azure Automated ML, which will basically take typically tabular data and run loads of different models on that and basically figure out what the best model is. You can run experiments, you can do more complex things with pipelines, you can export the models and publish the models. So it provides a lot of functionality for being able to run and manage machine learning projects. I think I've been through some of these actual slides in the actual code there. So a bit about the cards that are running. You've got like an NVIDIA Tesla K80, which is the one that I was running on. You've also got the V100 if you want to spin up one of those. That was costing about 76 cents an hour or something like that to get that kind of a processing power on the low priority. If you want to do this at home, I mentioned the requirement for having a lot of GPU memory. So running on an RTX 3090 is probably the best. That gives you 24 gig of GP RAM. You could probably get away with it with a 3060. You could maybe load the models on that. However, the 3090 has the 10,000 CUDA cores, so it is incredibly fast at being able to train those models. I put this deck together. I don't know if you can actually buy an RTX 3090 these days, or if they're still sold out. But the way I got hold of one, I actually put in a request for one of these. They're a bit suspicious at a consultancy company where I put in a request for a $4,000, and this is exclusive of Mom's gaming desktop PC. And they're saying, Alan, why do you need a gaming desktop PC? And it's not the gaming desktop, it's just the 3090 that's in it that you can't buy for love or money anywhere else. But they do actually ship them in these Alienware PCs. Yeah, you can go big if you want to buy sort of really big data science workstations. They cost a lot of money. Also, hard drive space is going to be an issue. That was basically the data sets I was working with, 152 gigabytes and then 500,000 files. And this was all of the image files and various things I was creating for a number of different data sets. Okay, unfortunately I can't demo the training of the model because the GPU won't actually load the model itself, but I do have a couple of sample videos I can show you. So the first one I did was, if I go into AI data, into demo videos. I'm kind of worried about copyright. Last time, I think Erica, remember, I showed this F1 logo detection, which is basically using object detection to detect the amount of time in seconds that people get with coverage of their advertisements in Formula One. Unfortunately, we got caught out by YouTube's AI, which detected content from Formula1.com and immediately blocked the actual video there. So we got caught. No, let's not do that again.
Try one more time.
Yeah. So yeah, the first one I did was with my son James. I think he need to play it in open with a VLC. Yeah, that's going to be better. And you can see the target, and there's a source and the target there, so there should be music on this. Yeah. So it kind of came out okay most of the time. One thing that you really need to get is a constant background to be able to get it to actually work with the quality of the images. Any type of moving background, if the camera's moving, it's not going to work. And this Bruno Mars video was really nice because on the actual target, when we're taking the videos from Bruno, it's basically a fixed camera in a fixed position. It's always the same angle on his body, or it's usually the same angle. There are a couple of bits where it does actually change, and I actually cut out what was happening when it was generating those videos from a different camera angle. But the one I generated with myself, oh, I need to use VLC, I keep forgetting that. It worked pretty much. I'm not getting as good results as they were getting at MIT. I think another thing is about the scaling of that. I'll explain a bit about that later on. But as soon as the actual position changes, you get some really weird results when the camera angle changes. See if I can find those. Yeah. You can see there when it gets onto that position there. There's no actual source data with me in that particular position because it was always taken from that same camera angle. So it's really having a hard time, generating anything meaningful from that particular position. But it's kind of sort of okay in most of the actual positions when it's generating. Another thing is the actual dance moves that you use should be fairly similar to the actual dance moves that the professional dancer is using. So you've got the body within the right position. I'll try and illustrate that if I can go back to the Everybody Dance Now project. It's probably going to be in YouTube actually. There's one thing that I noticed that they were doing. They were basically following a lot of the ideas I tried to replicate. You can see that their results are a lot better than mine. I don't know if they've been running it for a lot longer. The model that I trained with myself had to be done fairly quickly in order to get it ready for this presentation. But if we go into the other examples. you see that they used Bruno Mars as the source subject, and then tried to have kind of fairly similar moves in the destination ones to be able to get the actual mapping there. In this one, they're actually getting the reflection on the window, which I thought was pretty impressive there. And there's another one with belly dancing, which was my favourite. See if I can find that one. Yeah. So that was the source subject, and there you can see they're making belly dancer-ish moves, and the results that came out there I thought were pretty good there with that one. So I mean, takeaways on this, if you see something that somebody has done at MIT and you think, wow, that's just too impressive, I'll never be able to do stuff like that, you know, try downloading the code. Most of the examples are available on GitHub. You can download it and you can get it to work. It's not too challenging. Most of the challenge was just understanding the language that they were using. I'm kind of new to AI, fairly new to PyTorch when I started this project. So when they were just mentioning very briefly how the actual code works, how we can actually train the model. I think we got the code on GitHub. Yeah. They were just talking about the instructions for training the local stage, training the global stage, and then how to test it. There's not really that much description there on how to generate the actual data, so it did take me a while to figure out what's going on. Whether you run it on premise or whether you run it in Azure ML, that's really up to you. If your boss is going to buy you a very big machine with a big GPU on it to either carry around or to be able to have at home, then you can consider running it on your local machine. In honest opinion, I'd say you need both. Before I got that machine, it was really hard to run stuff with only using the Azure machine learning, because you'd basically run your experiment. It would take 5 minutes for the experiment to run up, and then you'd basically used a single equals instead of a double equals somewhere in your Python code, and it just throws back an error. So you fix the error and do a deploy, and then another 5 minutes for the actual experiment to spin up. It's nicer to be able to just run it all of the time locally on your local PC. The advantage of using Azure ML is that you don't have to have your machine running 24/7 to be able to actually train the model. You can just push it up into the cloud and have it running somewhere else, which is going to save you a lot in electricity. It's also going to give you a lot of peace and quiet at home. And also the tracking of all of the models and all of the experiments. Instead of just having a bunch of files on your hard drive, you actually get all of the statistics about how the model has been trained, all of the various files as well. And for a team of people working on an ML project, it's really good to consider and take a look at using the Azure ML technologies. I'd say this was the simplest part. I thought it would be fairly challenging to get this code running in the cloud, but it was very straightforward. And I've done this with other models as well, training image classification, object detection. Very easy to just throw it up into Azure and get things running there. Okay, so I think my time's up. Happy to take any questions before we move into the panel discussion.
Cool, thanks, Alan. I'm just going to set this up and we'll switch to the panel quickly. Do you want these chairs for the panel?
I think there's a question. Do you have a question there at the back?
Come on.
I can see you have a question, but you're afraid to ask it.
Here you go.
Thank you. Thank you, sir, for nice presentation.
Thanks.
I want to know that which language you used for your computer vision. Is it Python or like JavaScript or?
Yeah, Python.
Okay.
To actually work with the code in Azure ML. Microsoft has taken big investments in Python. That's something that maybe Henk can give more on the background of. But I did start off with learning something called ML.NET, which is a .NET machine learning library. I didn't, to be honest, get too far with it. Very quickly I discovered that if you want to work with AI and machine learning, then Python is really the way to go. And so Microsoft is doing so much for Python developers now with the Azure ML. All of the examples are in Python. So it's pretty much the language I try and work with most of the time nowadays.
Thanks.
Yeah, I have another question. How did you come across this project in the first place? How did you come across this project?
Google's AI. It just recommends videos that you might be interested in. It just popped up on on the front page of YouTube, and I just clicked on it and thought, wow, this is really cool.
Yeah, because when you show the first shot, that's like, okay, do they have some sensors that guide them up to that? Just the first little clip that you show in the first.
No, to actually do the pose detection, they're using something called open pose. So I'm assuming what they've done is they've trained a network using like a bunch of images, and then if you've got like the Xbox Kinect controller, that basically generates a 3D skeleton with all of the actual permissions. So by training a network to be able to generate the 3D skeleton from the actual individual poses from the photos, that can basically run. I wish I could show it on my machine, but it's just so slow. It will take in an image and it just generates the skeleton data for all of the people within that image.
All right, cool.
Well, thanks. Can you tell me where you...
Excuse me, I want asking some. Yeah. Thanks for presentation. But I just want to know, when you're starting the program, the project, do you have challenge something like you have prepared something like knowledge, something like before you make it?
So sorry, when I...
No, before you starting this project, do you have something like prepared, something have challenge, something like that, have knowledge before that?
No, I just did it for fun. I wanted to learn more about Azure ML. I wanted to just basically learn more about the generative AI.
Okay.
So I tend to have a lot of hobby projects where I just basically want to explore certain things with AI, and I just thought it would be a fun thing to look at.
Okay. For how long you can finish the project, something like that? For example, dancing.
Yeah, I don't know where it's going to go. I think it's fun to show to people as an example of AI, and then I think seeing something really complex and then being able to provide a bit of an explanation of how that works and what actually goes inside. I really love to understand, how they can do that, and I think just my curiosity for understanding how that solution works and then helping other people to understand how that works is useful.
Okay. Do you have something special tools when you make this project?
No, I'm just using Python code.
Okay.
Running it in Visual Studio. Yeah.
Oh, thanks a lot.
Any more questions? No? Okay.
3-minute break. Please don't leave. Come back.
Hi everyone and welcome to a new episode of the A Bit of AI show. The A Bit of AI show is all about the people behind the AI systems. What do they do? How did they get to this point in their career? And we're going to kind of find out what they do actually when they're sitting behind their computer. So my name is Henk Boelman and I'm a cloud advocate at Microsoft. And today I'm very excited that I'll have 3 guests. So we have Aisha, Corey and Alan joining me today. Thank you all for joining me today. We will start with a quick round of introductions. So I'll start with you. Can you tell me who you are and what you do in your daily life?
I'm Aisha. I'm researcher at Stockholm University Department of Computer and System Sciences. So mostly my focus is on my work. I'm also developing tools. I'm a software developer, so work on it and do research, study papers, study literature, find out limitations, work on it. So this is my work.
Cool. So what is your latest research on?
Yeah, my latest research is on Explainable AI, and I gave demo about that. So it was developed a tool for student self-regulation. So it was published in last year, October.
Amazing. We will share the link in the comments to that research.
Yeah.
Corey, thank you so much for joining me. Can you also quickly introduce yourself?
Thank you for coming to the reactor. Yeah, my name is Corey. I am an AI cloud advocate here at Microsoft. So I'm like Hank, but I don't travel the world. I don't have a cool show, but I do have this great space here for hosting events and engaging the Stockholm community, which are behind the camera that you can't see, but they're lovely people.
So can you tell me what the last thing you did for work?
The last thing
maybe not today.
Well, the last thing I did for work, I had a starting your AI builders journey workshop here in this reactor, where I was trying to help people navigate the world of all the different AI tools and platforms are out there. It can be overwhelming if you're just starting out. So it's just kind of helping them navigate the journey, what tools to choose, and how to choose them, basically.
Excellent. And we can always, is that also online available?
It is, YouTube, Reactor.
Of course.
Yeah.
Alan, can you introduce yourself and tell me what you do in your daily work?
Yeah, Alan Smith from the north of England. I've been in Sweden since about '98, I think. So a long time resident in Stockholm. And I work at a company. We do lots of projects. Most of our projects are focused on the Microsoft Azure platform. So we've been looking at opportunities for the customers to start working with the AI technologies. Lots of interesting cognitive services and the AutoML stuff. We're also looking for customers who are interested in more in custom vision. That's really my thing. I like working with custom vision and images and stuff like that. So it's good to look at those types of technologies. I also do a lot with training. I've just finished updating one of my Pluralsight courses, and I've been, I think I've got another 2 or 3 classroom courses before the summer break.
Oh, excellent. Yeah, I learned a lot from your Pluralsight courses, because I am also started out as a developer in this space and starting to learn. So your courses were really helpful for me.
Yeah, thanks.
So I'm wondering, today you went to work, or maybe you had a day off, but I assume you went to work. So what did you do?
I was actually on this thing called WAB today. My son was ill. I don't know how it is where you are, but in Sweden, you can basically stay at home with your kids when they're not well and at school. So I was playing Plants vs. Zombies Garden Warfare 2 with my son for quite a lot of the day. But what I should have been doing is preparing for the conferences. This session that I've done, I think I've got another 3 conference presentations before the summer. I've got one for, I think I've got 1 or 2 for Tekorama, and then I've got one for IGLUConf as well coming up, which I'm looking forward to.
What is it about? What are the sessions about?
They're all AI ones. So I'm doing another one on this Everybody Dance Now that I've done previously. And then I've got another one which is fairly similar. It's talking about neural networks from 0.0 to Dancer, where I basically go through explaining what a neuron is on the first slide, and then finishing off with talking about how the generative AI works. But then going through a lot of looking about how convnets work with images and network design and various things that you can do and can't do with neural networks.
Oh, that's going to be interesting.
Yeah, hopefully, yeah.
So, in the Bit of AI show, we have something that is called a lightning round. And that is kind of something to get to know all of you a little bit better and get some secrets out of you that I don't dare to kind of ask directly. So let's start with Ellen and then move to here. We start with you.
Oh yeah.
Okay, so first question. What was your first computer?
It was a ZX81, 1K of RAM Z80 processor, then graduated to a VIC-20 that had 3.5K of RAM.
Amazing. Yeah, didn't fit that model you just demoed.
No.
No. Corey.
I know I'm going to lose my developer card or techie card because I do not remember the exact specs of my first computer. I know it was an IBM. I remember just using the command line. My dad brought it from work, and yeah, I've just been using computers ever since. But yeah, sadly, don't remember the specs.
Yeah, same case with me. I'm not exactly remember that, but it was an old computer. My brother used it, and and just they gave me. Okay, I have bought a new one, and you take it.
Oh yeah, that happens for me too with my with the one of my dad. Do you remember which operating system was running on? Because that kind of sketches the age.
No, it was Windows, but its version was like a little bit old.
Okay, that is good. So next question. So the Bit of AI show is all about like learning new stuff. And kind of in our jobs, like every day there is like a new paper published, or there is some new tooling, or there is like so many different new things. So my question to all of you is, how do you keep up? What do you do to kind of keep up to speed and gain new knowledge?
Yeah, daily one paper. Daily, I daily read one article of my interest, of my research area, like related to education domain, but it's explicitly on. Nowadays, I'm working on explainable AI, so that's why. But daily one paper and try to implement it, but if get time, otherwise.
Yeah. So how long do you spend on that? Like like half an hour a day?
I actually read paper very slowly because I compare the other paper that I previously read. So that's why it takes some hours, like 3 or 4, not 1 or half hours. No.
Yeah, that is a lot of time during the day to do that.
Yes, I spend, and I think so. It's good because I compare with the previous work, and then I make my own inferences, and then I have to make notes for that. So that's why I give time to the paper study.
Okay, so in summary, you just every day you pick a paper.
Yeah.
You kind of read through it, compare it with all the other papers you've read,
Yes.
and then actually trying to do it.
Yes, and not actually, I make some inferences, and if I want to, I have some ambiguity, so to clarify it, and try to implement it, there's some work, yeah.
Excellent. Same for you, Koi.
Yeah, I mean, I would love to say I sit down every morning with my cup of coffee and I read the latest paper, but I have 2 kids, so I'm not going to lie that I do any of that. I think my main source of the latest AI news comes through podcast, largely because I can put my headphones on, my hands are free, and I'm a proud listener of about 1.75x, progressing to 2x on the podcast, so I can also get through the podcast quite quickly and learn the information, so yeah.
Excellent. So podcast.
Yeah, there you go.
Yeah, I always try to have a hobby project going. So I've been kind of resurrected this dancing project because I've got some presentations on that. But before that, I was looking at, I was into music genre classification. Do you know you can actually do music genre classification with custom vision?
Nope.
It works. You can just feed in, like, to convert the spectrograms into images, and the image classification will do music classification. So that was fun to look at. But I was also looking at using the is it YOLO 5 or something like that for music classification. There's a guy who's got a really good YouTube channel that talks all about music classification and how you can do it with PyTorch and PyAudio and all that stuff. So that was fun. And then I was also looking at a few YouTube channels that I follow religiously. Centdex, I don't know if you've come across him, he has great stuff on. It started out with just learning about Python, so there's lots of introduction to Python, but then he has these crazy projects where he builds like an AI to play Grand Theft Auto and an AI to play StarCraft and all this type of stuff. And he'll do like you know, a series of 12 videos on how to work with those scenarios, as well as some more serious and more work-orientated stuff. And then I think Jeff Heaton as well, he's a teacher at university, and he has a good YouTube video as well. But mostly I'd say I learn a lot of my stuff from YouTube, just watching through and then coding through as well. I like to be very hands-on and kind of code along when I'm watching YouTube. That's how I learn.
Excellent. Yeah, so I think you did also one presentation on like winning StarCraft.
Yeah,
creating the AI.
A couple of the Sendex projects, like the self-driving cars, that's kind of what first got me into AI, was just looking at the self-driving cars stuff where you can do evolutionary learning for self-driving. That ended up being the lab on the Global AI Bootcamp, managing to adapt a Microsoft sample racing game to actually learn how to drive around the track and beat humans. That was a fun project to do, and see people around the world being able to actually play around with that AI.
Yeah, so for people who don't know it, the Global AI Bootcamp is a bootcamp that is taking place all over the world in around 200 to 300 different places. So everyone can join like a local bootcamp and participate in workshops, in talks, in sessions. And the last 2 years it was all online, but hopefully this year we will be able to gather in person and learn again. And Alan, for one of the bootcamps, he wrote this really cool game that all the venues could play against each other. And then we had like this big scoreboard about which one was trading the best model. And it was really cool. Lots of people participated in.
Yeah, it's great to see you know, the pins appearing in the map around the world and seeing all of the stuff. I was involved with the original Global Azure Bootcamp way back in 2012 or 2013, I think, the first one. And the original idea was we were getting out. We'd be really excited if we had 35 regions around the world doing this, and now it's up to about 250 with the Azure one, and there's an AI one, and there's a DevOps one, and there's an integration one. It's going crazy. It's really good to see.
Yeah, it is really, really good. I think the Global Azure was like 2 weeks ago, also here, Corey?
Yep.
Yeah. Cool, so now kind of we know how you learn now, but you all already had a career for like a certain period of time. So I would like to kind of know how you got to like kind of this point in your career. Like, what did you study and how did you move to your career part now, actually working and doing AI projects? So the microphone is at you, Alan. So.
I started out, I'd always been hands-on. I mentioned that I'd always been tried to kind of be ahead of the curve on everything. So I kind of guess it started at university in my final year. I'd done a year in industry, and I remember being in a bar drinking beer with somebody who worked in the IT business, and he says, "What language are you working with?" I says, "Pascal," and he just laughed into his beer and said, "You're never going to get anywhere with that. You need to learn C if you're going to do anything in the IT industry." So I went back, did my final year project in C when everyone else was working in Pascal, and I've always, before that, there wasn't actually an internet, but they talked about this thing where you could talk to other people in other countries on some kind of network, and we just went, yeah, and ignored it. And I just read books. So I used to go out and buy, books on, C programming, learning C++, and all that type of stuff. Worked with a lot of hands-on stuff, but I don't know how you learnt back in the day when there was no YouTube and no internet, and you couldn't type a question into Google and get a code sample that you can copy and paste.
And definitely just copy and paste, right? You actually had to go in the book, and then if there was a typo in your book, happened a lot.
Yeah,
you were kind of stuck.
On Monday, the internet shut down for a whole day at my place, and it felt like I couldn't look up anything or do anything. I was kind of stuck with the knowledge that I have for writing Python, which is pretty basic. I couldn't remember a lot of stuff I needed to do, and it's really hard without the internet. So it's easy today.
Yeah, thanks. Yeah, so my journey, so first traditionally did a computer science degree. University in the US is very expensive, and I got very bored of that because why pay for something so much that you already kind of know? So I stopped doing that, and I finished my degree in rhetoric or public address, so speaking, which luckily made me persuasive enough to go back into tech after a few odd jobs, and then I was working mainly on API integrations. So first e-commerce side, and then in payments. So not very cool payment side of things, but super important, obviously driving the economy. But I actually got into AI through this meetup group that we are here at now, and kind of full circle because we had the first meeting ever, so I wasn't founding of this, and we had like a kind of tour of all the different AI concepts. And one of the concepts that came up to me was the generative adversarial network. So people watching the video won't know, but Alan just gave a talk about that, and I volunteered to give a talk, not knowing anything about AI, and again, kind of the same thing. Oh, this is supposed to be for MIT and Harvard, PhDs, but sure, I'll do a talk next meetup. And yeah, it went okay. Surely not as good as Alan's, but now I'm here 3 years ago almost. So yeah, it's been a crazy fast journey.
Thank you for sharing.
And in my case, I was studying, and along that I was also doing job. I was working with different software developers and website developer, and then I learned about website development and software development skills, also studying. And after my master's, and I did work with a PhD student for sentiment analysis as an assistant. After that, during my MS program, I worked in healthcare domain by using machine learning techniques to detect automatic detection of epilepsy. It's a mental disorder. So after that, I came in a education domain, and now I'm working in it. Yeah.
And now you're here
Yes,
talking and
yes.
sharing all your knowledge. Oh, that's so fun. That's so cool. So a lot of different journeys into into the AI space. So we're going to round up with the final question. So we all know what you are doing now and what you've learned so far. So I'm very curious in what is next, the kind of next thing on your agenda, what you want to learn.
Okay, the next is currently I'm working for tools for education domain. So my basic goal is to provide quality education to the students. So my motive behind my work is this. So that's why I will focus on it and provide more automated technology-based tools to the different education stakeholders. Yeah, this is my goal.
Excellent. I hope you succeed.
Yeah, for me, so I've been mainly an AI generalist for the last couple of years, just learning about AI concepts. But I'm really interested now in sort of the application in other future technologies, if you will. So things like VR, space exploration. There's many open AI applications to that. Whether people can launch a satellite if just normally as a normal human being now almost. So what do you do with all those images that we're gathering from the satellites? How can we predict climate changing and things like that, as well as in virtual reality, everything is made up in virtual reality. And AI, as Alan had proved, AI is really good at making things really quickly. So now we can make entire worlds generated by AI. What does that mean to people? How does the technology work? And then how do we put that in society? So I'm very interested in those spaces.
Yeah, I kind of want to learn more about the basics of how stuff works internally. It's easy to download something from GitHub and run that code, but understanding more about model design and effective model design. I've been looking at, training different neural networks when I was doing the music genre classification. Why should you choose 57 layers or 15 layers or 18 layers? What should you set as a learning rate? How long should you train for? And I think a lot of that stuff is built up with experience, just to gain more experience of just working with those technologies. And I'm going to probably stay in the custom vision space with ConvNets and look at how they work. I've also been looking a bit at object tracking as well, which is interesting. I know Microsoft's got a good offering there with doing all the people tracking. I can't remember, what's it called, that technology? Part of the, you track people in shops and see, you know, how the customer flow is in shops and things like that.
It runs on the Percept, right?
Hmm?
It runs on the Azure Percept.
I think so, yeah.
But what it was, I
can't
don't know.
remember the name of the technology there. But looking at doing something like, you know, having a web camera be able to count the number of cars, analyse traffic flows. I cycle a lot into Stockholm, and sometimes, you know, there's as many bikes. Seems like there's more bikes going into town than there is cars. And it'd be nice to be able to build up statistics on that and be able to build solutions that use the object tracking, which is kind of built on top of the object detection.
Cool, I'll feel a new project and a new presentation coming up in like the next year. So I want to thank you all for joining me into in the Bit of AI show. And everyone at home, thank you so much for listening, and I hope to see you next week.